Okay, so far we've covered how to solve a triangle that has a right angle in it. We know that no matter what we're solving, whether it's one of the angles here or whether it's one of the side lengths, one of the side lengths like our hypotenuse or opposite side or our adjacent side, we know that we're going to use something like SOHCAHTOA. We're using one of those three primary trigonometric ratios. Now, we also know, because we went over it, we know how to handle it if there is no right angle in the triangle. If we have an angle A here, side length A, an angle B here, side length B. So, we can use this method here, and that's our sine law. We can use this method when what we're working with are two angles and two side lengths. But because of the way the sine law is set up, and it's, if we were using it, then it would look something like sine of angle A over A equals the sine of angle B over B. Because of the way that's set up, we need to have two different side lengths and two different angles in order to get where we want to go. Now, how about if we have a triangle and we're working with three side lengths and one angle? We wouldn't be able to use our sine law, because our sine law, sine A over A equals sine B over B equals, even when we bring our third element into it, sine C over C, we wouldn't be able to use our sine law, because at the very most what we have here, so let's look at, I would have C, and even if I label this angle C, at the very most I have two pieces here, two elements of our equation, and then I have only one element in either of these two sides of the equation, so I could never build up something that I could use in order to solve for one of the unknowns. So what we're going to do today, it's called the cosine law. This is going to be the strategy we use when we're set up with a triangle, when we're working with three sides and one angle, regardless of which is the unknown, if it's one of the side lengths or if it's the angle. If we label side length C opposite to one of the angles that we're working with, then our sine law can be written as follows. C equals the square root of A squared plus B squared. And we've seen something like this before, but here we're going to throw another wrinkle into it. A squared plus B squared minus 2AB times the cosine of angle, in this case we label it angle theta. That's what it looks like, and that might look a little bit intimidating, but we know how to square a side length, we know how to square another side length, and we know how to multiply things together. And this is simply multiplying the number 2 times the side length A times B times the cosine of theta. So you'll see how it works in a moment here, but it is fairly straightforward, even if the sine law itself looks a little bit intimidating. So let's try. I'm just going to move that down. And you know what? I will write here, so you can remember, always label C opposite to the angle. Perfect. So let's take a look at our first example, example A here. Now, there are no labels in terms of A, B, C, or theta, but we are given some things to work with. So I do have one angle here, and that's 56 degrees, because that's the angle we're working with. And we notice, as I alluded to earlier, We notice this time we would not be able to use our sine law because what we have are 3 side lengths and 1 angle. So we'd not be able to use our sine law. Let's jump in with our cosine law. So this would be angle theta. We always go opposite that in order to find our angle C. And then the other two we can label however we wish. I could have A and B as my side lengths, or I could have A and B. So let's work with it labeled as it is now. I'll start off by writing out my sine law. That's C equals the square root of A squared plus B squared minus 2AB times the cosine of theta. And now I can substitute in what I know. Well, I don't know the side length C, so we'll leave that as an X. I do know side length A, that's 8. So 8 squared plus, and I do know B, that's 12. 12 squared minus 2 times A, and that's 8, times B, and that's 12, times the cosine of 56 degrees. And we can't forget all of this is getting square rooted. Okay? So we can simplify a few things all in one line here because they're separated. So 8 squared, if I put that into my calculator, that's 64. Plus 12 squared, I can put that into my calculator, and it is 144, sorry. 144 minus 2 times 8 times 12, and I'm just going to leave those as is for now. 2 times 8 times 12 times the cosine of 56. So let's calculate that now. 56 degrees, the cosine of that is 0.56. 0.56. Again, all square rooted. And here we're following our order of operations. We're solving what's underneath our square root sign first. So I have 64 plus 144 minus, and then what I can do is I can throw all of this into my calculator because this is 4 different things that are getting multiplied together. So I have 2 times 8 times 12 times 0.56, and that equals 107. Equals approximately 107. All of that square rooted. And now, because I have 3 terms underneath my square root sign, they're separated by plus and minus sign. So I can, calculate all of those at once from my calculator. 64 plus 144 minus 107. It comes to 101. So square root of 101. And if I take the square root of that, then it's something very close to 10. It's 10.05. Perfect. So therefore, x equals 10.05. And that's how we use our sine law. Notice that although the sine law looks a little bit convoluted, it is quite straightforward in that we're just using math that we've been using for years. We're just using our BEDMAS here to find out the unknown side. Now let's try example B. It looks very similar. So I see my angle here. That's 81 degrees. So opposite 81 degrees, I have my side length C. And I'll just separate those, and I can write down my sine law once more. C equals the square root of A squared plus B squared minus 2AB times the cosine of theta. So now note, for this sine law, I'd never have you need to spend the time memorizing it. I would provide it on a test for you. And I can substitute in what I know. I know c equals x, and then I can label either of these sides, a or b, it doesn't matter. We'll go with a and b. So equals the square root of a squared, so that's 8.4 squared, plus b squared, and that's 11.0 squared, minus 2 times a, which is 8.4, times b, which is 11.0, times the cosine of 81 degrees. And that's all under a square root sign. So just like last time, I'm squaring my a and b here. So 8.4 squared is 70.56. My 11.0 squared is 121. Minus, and again, I'm going to leave all of these here, 2 times 8.4 times 11 times the cosine of 81. So I'm going to find out the cosine of 81 right now with my calculator, and it's 0.16. Again, all of that square rooted. And I'll leave the first two terms together, 70.56 plus 121 minus, and then I'm going to multiply all of these together, these four numbers. So 2 times 8.4 times 11 times 0.16 equals 29.6. 29.6. I can take these three numbers just as I did last time, and I'll add and subtract them as it tells me to. So 70.56 plus 121 minus 29.6 equals 161. 161.96, still square rooted. We need to make sure when we're working through this, we keep our square root going on every single line that we're working here. So the square root of 161.96 is 12.7. It's approximately 12.7. So therefore, x equals 12.7, and we do have units here, they're millimeters, so 12.7 millimeters. That's how we can solve for the side lengths there. We'll see how we can use our sine law our cosine law to solve for an angle now. So I'm going to give you another tool in your arsenal, and that's another form of our cosine law. And this form is useful if you're trying to find out an unknown angle. So cosine of theta equals a squared plus b squared minus c squared, all divided by 2ab. I can use this when I'm trying to find an unknown angle. I can use this when I'm trying to find an unknown side length. So let's work with this now and see what we can do with it. So the cosine of theta equals, and again I'll provide you with both versions of this formula here. The cosine of theta equals a squared plus b squared minus c squared, put all of that in brackets, divided by 2 times a times b. Well, I don't know what theta is, so I'm going to still leave it as is. But I do know what a is, and that is 6. So 6 squared plus, and I know what b is, that's 5. So 5 squared minus, I'm just substituting in my known values here, 7 squared, all divided by 2 times 6 times 5. And I can put that in brackets there as well if I'd like. And we'll simplify this. So 6 squared into my calculator is 36, plus 5 squared, which is 25, minus 7 squared, don't forget this minus sign, is 49, all divided by 2 times 6 times 5, and that's 60, if I use a calculator. Now, I can quickly perform the operations happening in my numerator here within the bracket, so that's 36 plus 25 minus 49, and that's negative 12. Sorry, that's positive 12 divided by 60. If I put that into my calculator, that's 0.2. So I have cosine of theta equals 0.2. I'm not done because the goal is to try and find out what theta actually is. But I have seen questions like this before. I know how to deal with them. I use the inverse function on my calculator, so the inverse of cosine theta, and I'll move this over, equals the inverse cosine of 0.2. And inverse cosine and cosine cancel out, leaving me with theta on the left-hand side, cosine of 0.2, which I can put into my calculator. So the inverse cosine of 0.2, and that is about 74 degrees. So this, again, it's fairly straightforward. We're just plugging in our known values into a formula. We'll try that once more for B here. So I know my theta. The first thing I need to do is label my C. That's opposite of my theta. And I can label A and B however I'd like. And my formula for an angle, my cosine law for an angle, is cosine of theta equals A squared plus B squared minus C squared, all divided by 2 times A times B. And then I can substitute in my known values. So the cosine of theta equals A squared, which is 14 squared, plus B squared, which is 12 squared, minus C squared. Don't forget that minus sign, which is 8 squared, all divided by 2 times 14 times 12. And I can put these into my calculator. So 14 squared is 196, plus 12 squared, which is 144, minus 8 squared, which is 64, all divided by 2 times 14 times 12, which is 336. And now I can calculate what's inside my brackets here. So 196 plus 144 minus 64 equals 276 divided by 336. Well, I can plug that into my calculator as well, and I get 0.82 approximately. And I still have my cosine of theta on my left-hand side. The goal here, once more, is to isolate for theta, and that means I need to take the inverse cosine. If I do that on the left side, I need to do it on the right side here. My inverse cosine and my cosine cancel out, leaving me with theta equals the inverse cosine of 0.82, which I can use my calculator to find that it equals about 35 degrees. So that's how we'll solve these problems. Now we should be ready to solve almost any triangle that comes our way.